Hello students, today I am going to discuss the topic of Unit 5 Receiving System of Elementary Communication Engineering. And these are the contents. Please go through it. Now, the part is block diagram and principle of superheterodyne receiver. So, the figure shows the block diagram of a superheterodyne receiver. All the drawbacks in TRF. TRF means tuned radio frequency receiver is the simplest radio receiver. There are some drawbacks. So, to remove the drawback, superheterodyne receiver is developed. The basic superheterodyne receiver is most widely used. This means that the superheterodyne principle is used in all types of receiver like television, radar, actually television receiver, radar receiver, etc. In a superheterodyne receiver, the incoming RF signal frequency is combined with the local oscillator signal frequency through a mixer. You all see in the diagram, and is converted into a signal of a lower fixed frequency. The lower fixed frequency is known as intermediate frequency. However, the intermediate frequency signal contains the same modulation as the original signal. This intermediate frequency signal is now amplified and demodulated to reproduce the original signal. So the word heterodyne means mixing. Here we have mixed the incoming signal frequency with the local oscillator frequency. Therefore, this receiver is called superheterodyne receiver. In superheterodyne receiver, a constant frequency difference is maintained between the local oscillator signal frequency and incoming RF signal frequency through capacitance tuning, in which the capacitance are ganged together and operated by a common control knob. So the IF amplifier generally contains a number of transformer, each consisting of a pair of coupled tune circuits. So, with this large number of double tuned circuits operating at a specially chosen frequency, the IF amplifier provides most of the gain and bandwidth requirements, that is sensitivity and selectivity of the receiver. This means that the IF amplifier determines the sensitivity and selectivity of the superheterodyne receiver. Actually, the sensitivity and selectivity of the superheterodyne receiver are quite uniform throughout its tuning range. So, there are some advantages of the superheterodyne receiver. Make it the most suitable for the majority of radio receiver applications like AM, FM, communications, etc. So, what are the advantages? Number 1, no variation in bandwidth. Number 2, high sensitivity and selectivity. And number 3, high adjacent channel rejection. High adjacent channel rejection. Here the range of intermediate frequency is 455 kHz and IF bandwidth 10 kHz. So I believe this is clear to you. Now basic idea of some parts of the block, that is selector, mixer, detector, AGC, speaker and tone control. So what is selector? When radio wave from various broadcasting station are received by the antenna, a tiny EMF is induced in it. As the selected radio wave become weak, therefore need amplification, which is the reason of RF amplifier introduced. And next one is mixer. The amplifier output of RF amplifier and output of the local oscillator frequency actually are fed to the mixer stage. These two frequencies beat together and produces an intermediate frequency. We see in the previous diagram, the IF intermediate frequency is the difference between the oscillator frequency and selected radio frequency. And the next one is detector. Usually diode detector circuit is employed because low distortion. Here audio signal extracted from IF output. Next AGC, we all know automatic gain control. It stands for automatic gain control. It controls the gain of IF amplifier, selector, RF amplifier automatically. And next one is speaker. It is the device which convert audio signal into sound wave. And next one is tone control. Modern audio frequency amplifier are designed to give frequency response over whole audio range from 16 Hz to 20 kHz. Somebody likes the depth of sound which is given by low pitch or low notes. For them, it should be amplified more than high notes. This is basic idea of tone control. So this diagram is the block diagram of FM receiver. You all know about it. It is similar to the superheterodyne receiver. It is similar to the almost superheterodyne receiver. There is AGC and here that is AFC. Because this is FM receiver, so frequency control is mandatory. So AFC is needed, that is automatic frequency control. And mixer is mixed the frequency of RF amplifier signal and the oscillator signal, frequency of oscillator signal, and the signal is fed to the IF amplifier. So from the demodulator we get the demodulated output. So this is same as superheterodyne receiver almost. So now the next part is receiver characteristics. So because the type of receiver is almost the same for various forms of modulation or system, therefore it is generally most convenient to explain the various principles of a superheterodyne receiver. So let us discuss various superheterodyne receiver characteristics. Sensitivity, selectivity, fidelity, these are the most important characteristics, and also there are double spotting, tracking, etc. So, the sensitivity of a radio receiver may be defined as its ability to amplify weak signals. It is generally defined in terms of the voltage which must be applied at receiver input terminals to provide a standard output power measured at the output terminals. So, for AM broadcast receivers, several relevant quantities have been standardized. So, sensitivity is expressed in microvolts or in decibels below 1 volt and is measured at 3 points along the tuning range. So, few factors which determine the sensitivity of a superheterodyne receivers are as under: the gain of the IF amplifiers, the gain of the RF amplifiers, the noise figure of the receiver. Those are the few factors. So, the gain of the amplifier, the gain of the RF amplifier, and the noise figure of the receiver. Please remember it: gain of IF, gain of RF amplifier, and noise figure of the receiver. And the next one is selectivity. The selectivity of a receiver may be defined as the ability to reject unwanted signals. It also expresses the attenuation that the receiver offers to signal at frequencies adjacent to the one to which it is tuned. It may be noted that selectivity depends upon some factors. Number 1, it varies with receiving frequency. Number 2, selectivity is the main factor which determines the adjacent channel rejection of a receiver. And in general, it is mainly determined by the response of the IF section. Now, fidelity. The fidelity is the ability of a receiver to reproduce all the modulating frequencies equally. The fidelity basically depends on the frequency response of the AM amplifier. High fidelity is essential in order to reproduce a good quality music without introducing any distortion. For this, it is essential to have a flat frequency response over a wide range of audio frequency. And also there are double spotting and tuning of a superheterodyne receiver. When a receiver picks up the same short wave station at two nearby points on the receiver dial, the double spotting phenomenon takes place, and the main cause for double spotting is poor front end selectivity, and tuning of a superheterodyne receiver is also needed, because in a superheterodyne receiver the local oscillator frequency is made. You see in the block diagram, it is made to track with the tuned circuit, which are tuned to the incoming signal frequency in order to make a constant frequency difference at the output of mixer. I think these all are clear to you. So, the next part is pre-emphasis. It has been proved that in FM, the noise has a greater effect on the higher modulating frequencies. This effect can be reduced by increasing the value of modulation index. We know about modulation index for higher modulating frequencies. This can be done by increasing the deviation of frequency and it can be increased by increasing the amplitude of modulating signal. So, if we boost the amplitude of higher frequency modulating signals artificially, then it will be possible to improve the noise immunity at higher modulating frequencies, right? So, the artificial boosting of higher modulating frequencies, remember the artificial boosting of higher modulating frequencies is called as pre-emphasis. So, there is a pre-emphasis circuit. Boosting of higher frequency modulating signal is achieved by this circuit. And the modulating AF signal is passed through a high pass RC filter, that here R1 and C, high pass RC filter, before applying it to the FM modulator. So, as FM increases, small FM, that means higher modulating frequencies, as FM increases, reactance of C decreases and modulating voltage applied to FM modulator goes on increasing. The boosting is done according to the prearranged curve. You see here, the amount of pre-emphasis is in US FM transmission, and sound transmission in TV has been standardized at 75 microsecond. The pre-emphasis circuit is basically a high pass filter. The pre-emphasis is carried out at the transmitter and the frequency for the RC high pass network is 2122 Hz. Please remember 2122 Hz. Hence, the pre-emphasis circuit is used at the transmitter as shown in the figure. And this is the block diagram. FM transmitter including the pre-emphasis. Actually, after pre-emphasis, FM before applying it to the FM modulator, pre-emphasis is needed. I think this is clear to you. Now, the next part is de-emphasis. So, the artificial boosting given to the higher modulating frequencies in the process of pre-emphasis is nullified or compensated at the receiver by a process called de-emphasis. So, we know that actually by boosting the modulating frequencies or the boosting of the amplitude of modulating frequencies, artificial boosting of higher modulating frequencies is called as pre-emphasis. We all know that, and this artificial boosting is given to the higher modulating frequencies in the process of pre-emphasis sometimes have to nullify. So, the pre-emphasis is nullified or compensated at the receiver by a process called de-emphasis. The artificially boosted high frequency signals are brought to their original amplitude using the de-emphasis circuit. So you see it in this diagram. There are FM demodulator, de-emphasis circuit is a RC circuit. So the demodulated FM is applied to the de-emphasis circuit, which increase in FM, the reactance of C goes on decreasing. And the output of de-emphasis circuit will also reduce from the de-emphasis circuit. So remember it once again that the artificial boosting given to the higher modulating in the pre-emphasis is nullified or compensated at the receiver and bring back to the original signal. Actually, bring back to the original signal, de-emphasis is needed. Please remember it. I think all topics are clear to you. So, if you have any doubt, please feel free to contact me. Thank you.